thank you all for being here. We're going to be discussing as part of this panel, how do we accelerate the green metals production. So my name is Frederic Ozer. I'm a partner with Oliver Wyman, and I'm joined by three panelists who actually have a very practical experience of how to decarbonize metals. So why don't you please quickly introduce yourselves, Tadeu.
My name is Tadeu Carneiro. I'm the chairman and CEO of Boston Metal. I'm a metals veteran, worked with metals my whole life, very linked to all sorts of different metals, but especially with the steel industry.
Thank you.
My name is Nicolas Ber. I am the CEO of CAP. CAP is a Chilean, very old Chilean company. And now we are in basically iron ore, rare earth. We have an industrial division that has two projects that we will comment a little bit more, and the infrastructure division.
Good afternoon, everyone. My name is Irina Gorbanova. I'm head of X-Carp Innovation Fund for ArcelorMittal, which is one of the largest metal and mining companies globally. And pleasure to be here. I've been in the industry for more than 20 years, so very passionate about this particular subject, and very much look forward to the discussion. Thank you.
Okay, thank you. So allow me just to set the scene with a couple of slides, and then we'll move to the discussion with the panelists. So, what are we talking about? We know that metals production is responsible for about 9% of global energy-related CO2 emissions. While we have seen a reduction in the emissions intensity per unit or per unit of revenue, due to the sheer growth of that sector, still the CO2 emissions have increased significantly by around 50% over the past 6 to 7 years when we talk about mining and metals in general. So in this context, major metals and industry producers are planning a response to this, what we could call a challenge. Okay? And most of them have a near-term carbon reduction objective of around 30% between now and 2030 to 2035. So we have ambitious targets. We acknowledge that there is a challenge. Now, when we look at what has been achieved so far and what are the challenges ahead of us, we have around 5 to 6 main success factors that need to be put in place in order for this energy transition in the metal sector to happen. First, on technology, we will have the chance to discuss that. We are seeing already some achievements on that front, but still we have many challenges to tackle. Many of them are still in R&D and pilot stages. On the cost side, the cost of green hydrogen has been reducing significantly, but producing green steel is still way more costly than producing conventional steel by 20 to 40%. On the access to renewables, players have been more or less creative in how to get access to renewable, but we know that the availability of renewable energy and its supporting infrastructure remains limited for the sector. Regulation has played an important role in incentivizing green supply and green demand, but also constraining gray steel supply. However, we still foresee and see inconsistencies in global regulations. On the demand side, demand is expected to grow for green steel and green metals by about 5 to 6-fold in the next 5 to 10 years. However, we still have challenges in terms of awareness, certification, traceability of that demand. On the financing, we will also get the chance to talk about it. Several types of financing have been secured for the sector when it comes to loan, green bonds, and also venture capital and private equity coming into the game. However, project economics are still not favorable compared to the conventional steel and metals. So against this backdrop, I wanted us to engage in the discussion, and we will start with you, Irina. I mean, please help us also set the scene. We know that green metals is associated, as we have seen, with several challenges. Progress is being made, however, maybe not fast enough for some of us, maybe not big enough. Why is it even important that this industry goes green? And importantly, why is it important to accelerate that transition?
Thank you, Frederica, and thank you for setting the scene. And I'll speak specifically about steel. And quite often, to put things in perspective, I ask the audience a couple of questions around steel production, because interestingly enough, not everyone fully appreciates the massive challenge that we are dealing with. So if I can ask, how many of you know how much steel is produced globally per year? You know, anyone? How much? Just over 1 billion tons. That's a very good answer. So it's close to 2 billion tons of steel that is produced globally per year. And in accordance to various estimates, this number is set to grow to anywhere between 2.3 to 2.5 billion tons by 2050. And then the second question that I usually ask is how much CO2 is emitted per ton of steel produced through the traditional pathway of blast furnace. Excellent. So it's 2 tons of CO2 per ton of steel produced, emitted. So you can do the math, and that gives you the appreciation of the challenge we are facing, because it's just, I think Federici were putting on the slide 7.5%. So it's anywhere between 7 to 8% of global CO2 emissions are contributed by the steel industry. So that's the challenge we are facing. On the other hand, steel is such a versatile material, and it's a catalyst for the industrial transition. It's a catalyst for the energy transition and decarbonization. And it's not just about cleaning up our industry. It has a ripple effect across the multiple value chains. If you think about construction or buildings, you require so much steel. You think about, again, the infrastructure, the logistics, the data centers, a popular subject. Everyone is talking about the boom of AI. Data centers require so much steel. We speak about renewable energy. Think about wind towers, solar panels, just name it, electrical vehicles again. So steel is really, really fundamental for the energy transition. But it's really how we produce it. Can we produce it in a sustainable, low-carbon manner? So that's the challenge we are facing, and that's exactly what we're trying to accelerate, because you're asking, why do we need to accelerate this? Because it has such a ripple effect across the value chain. The good news, we are, as a group, we are committed, and I know a lot of other companies are committed to get to net zero. There are a number of pathways that we are pursuing, because it's not just one silver bullet that can get us there. It's really a complex, multifaceted challenge. And I always speak about innovation because I run XCarp Innovation Fund, but it's really about a number of technology pathways like DRI, based on hydrogen or at least natural gas as a bridge fuel. DRI stands for direct reduced iron. We're also looking at what we call smart carbon, so using some of the existing facilities, but really trying to minimize a carbon footprint by leveraging biomass, by leveraging CCUS, so really putting a number of technologies together to reduce the CO2 emissions resulting from these operations. And I was just reading McKinsey reports published a week ago on green steel, and the number I've seen is close to 1,650 steel facilities across the world that we need to decarbonize. So, setting the scene, it's, I guess what I'm trying to say, it's a massive challenge, but luckily we have a lot of people focused on trying to accelerate this decarbonization. I think that's the subject of our discussion today.
Yeah, thanks, Irina, and thanks for touching on technology. And I'll turn now to you, Tadeo. I think, and you've mentioned that, Irina, so there are several technologies that are being deployed today or tested today to decarbonize, whether it's HDRI, whether it's CCUS, and also molten oxide electrolysis, which is commercialized or being pushed by Boston Metal today and still in development. So which of these technologies do you think has the brighter future, has basically also a way into accelerating this transition?
I'm glad you asked me, so that's to answer this question. I'm very biased, of course.
Yes, of course you are biased for one of them. But then this is why we have two other panelists.
In any case.
Well, actually, I should have mentioned, of course, electrolysis because we also invested in
case,
Boston Metal.
It's a pleasure to be back here in this forum in Riyadh. It's always a pleasure to be invited, and I thank you very much, the organizers, for having us here. Well, the question starts with a very interesting thing that you have to think of, and Irina already mentioned. Steel, we are talking, if you want to decarbonize steel, you want to solve the problem for 2 billion tons per year. Well, some is recycled, but even if you find 1 billion tons of scrap, good luck, to recycle, you still need 1.5 billion coming from iron ore, right?
Yeah.
So you do have lots of different technologies that are being talked about and attempted and everything. But if you want to solve for 1.5 billion tons, the only technology that can scale up to that amount is molten oxide electrolysis. The others can help in a transition, right? So you take direct reduction, substituting hydrogen for natural gas.
Yeah.
Where is the hydrogen, right? And you have all sorts of different technological problems to solve that with DRI. I mean, DRI exists for 50 years, so people think that you just because DRI is there for direct reduction is there for 50 years, you substitute hydrogen for natural gas and boom, down that bad news. No. So where is the hydrogen, right? That's the first thing. Then you need premium iron ore to use direct reduction. So that's the other thing. But the easiest thing to see that molten oxide electrolysis would be ahead of the game is for the same electricity that you use to produce your green hydrogen, you can use to go directly from the iron ore to the metal. So molten oxide electrolysis is a one-step process. You add iron ore, pass electricity, get molten metal in the bottom of the cell to tap and emit oxygen in one step, right? So, and why you can do this with any iron ore is because the impurities in the iron ore are part of the electrolyte. So it's silica, calcium, magnesium, alumina. So this is as simple as that, right? So we are in the process of finalizing the scale up of the technology. We push the button to start a semi-industrial cell in Boston that will tap 1 to 2 tons per month of liquid steel, green steel. And from here, we will build the first industrial cell that will give 1 to 2 tons per day that we are scheduled to build in 2026, right? So other technologies like CCUS, I mean, you can add that and help in the transition, but then you have to remember that the U in CCUS is utilization. You have to find lots of utilization. The S is the storage. So you have to find where to put that stuff.
Yeah.
So so all these other attempts, they can solve for small quantities. Molten oxide electrolysis is the only one that once commercial will solve for the whole thing, right? And just one more comment. The steel industry is perceived as the most conservative industry in the world. Maybe they are, but if you look at the history, every time that there was a process that was proven to be efficient and solved for a problem that needed to be solved, they adopted very fast. The Bessemer furnace, then came, I mean, eventually the blast furnace. If you look at the adoption rate every time the process was developed, it was very, very quick. So once we have the solution to eliminate that, it can be adopted very quickly. And then, just to complete the answer, if you depart to other metals, which also need to be decarbonized, Take manganese, for example. Every steel has manganese. So you have to decarbonize everything. Well, then nature, some call it thermodynamics, that don't let hydrogen reduce manganese oxide. So if you want to decarbonize manganese for batteries or for steel or for whatever, you have to use electrolysis. You have to use molten oxide electrolysis. So that's why we are very excited at Boston Metal, and we are trying to push as quick as possible to get the final answer there.
Okay, so you're excited and optimistic, which is great.
Yes.
And we're going to get
Always.
back to the topic of innovation and technology. But let me turn to you, Nicolas, on the topic of cost. And we've seen quickly on the slides that it is more costly to produce green metals today and green steel, 20 to 40% on average. So there have been several supporting mechanisms or policies, if we want to call them, to push for green steel, whether it's in the EU with the Green Deal or in the US with the Inflation Reduction Act, the IRA. So to which extent, in your view, have these policies or mechanisms been impacting the demand and reducing basically some of the cost components of green steel? To which extent are they sustainable, and will they continue in the future as well? And what are other potential incentives that could be put in place in order to incentivize supply and demand in the right way?
Great question, Osid. First, I would like to thank FMF for the invitation. I think it's a great conversation. I just heard my friend Tadeu. I am very scared now because our mining strategy is based on high-grade iron ore. And I understood from you that your technology could basically smelt even low-grade iron ore. So I would be very interested to understand better how that works. I believe that those technologies will coexist for a long period of time until we decarbonize everything. But anyway, I will stop there and I'll go to your question. We see recently a little less enthusiasm in terms of the projects. They are going slower. And the reason of that is because hydrogen cost estimations are significantly higher, or were lower, than what we have today. So we still need more technology, or to let the technology evolve in order to have competitive costs against the natural gas. Natural gas intensity of emissions is around half what was mentioned.
Like 800.
Right? But the intensity that Tadeu's technology is basically zero, or almost nothing. So I think to arrive there, we have a long way, given the technology of hydrogen that we have today. We also saw or see now that the governments have withdrawn some of the incentives recently, a little bit. I mean, they are going to be slower. We see the European Union, we see the United States, and therefore, because of the fiscal deficit that they ran today after the pandemic, of course, it's more difficult for them to throw money or to invest money or to make the subsidies that we expected to have. So I believe also that in the conversation here in the FMF, the problem and the central topic is critical minerals more than green metals. And I think that's a little bit a reflection of what I have just commented. I believe that to continue on the green path, we need to do three things, or to strengthen three ways. The first is more global and clearer rules in terms of the regulation. Second, to continue strengthening the demand. And third, to continue incentivizing the supply. I go for the first. Three things. One, carbon leakage mechanisms should be global. So the CBAM cannot be only in Europe. We should have mechanisms that are very similar all over the world so you can enable global trade again. Right? Secondly, I think we have to be clearer and to standardize or uniform what means green. So we have to certificate what is green steel. Because green steel for a Chinese or for a European could mean significant different things, or for a Chilean. So I think we have to normalize that. And third, we need to develop more and to have better and deeper carbon mechanism trade or carbon trading mechanisms in order to comply with the CBAMs in a right way globally and across the board. So those are the three measures that I would promote in order to continue in the path of green metals, more than on the connotation, on the emphasis of critical minerals. On the supply side, of course, it's important to continue with the subsidies and with the grants. Hopefully, in the United States, are not cut or not diminished. The European Union, with the Green Deal, hopefully they continue. And all these programs that we have in Chile, also, for example, in hydrogen program, continues, and they are funded, and they are part of the budgets of the countries. And on the demand side, I think it's very important, for example, that the fiscal expenditures are focused on green investments. For example, in my country, a big bridge is constructed between the continent and a big island, Chiloé Island. I'm not sure if the government is putting an eye on the steel that we are purchasing or acquiring for constructing that big bridge. So government should preach with the example, or they have to be the first in demanding green steel. And of course, tax credits and those kind of things are very important. And also in regulation, I think it's important that we put as a requirement to show the scope 3. We have a very good example in the steel production in Chile. We provided to the mining sector in Chile the grinding balls. And today the mining sector is not necessarily very concerned about the scope 3. They are more concerned about scope 1 and scope 2.
Okay, great. Thanks, Nicolas. And we'll get back to you towards the end to discuss a bit more the financing part of all of that. So, Irina, I'll turn to you again, and it would be great also to hear your perspective about Tadeu's somewhat, I wouldn't want to say provocative, but at least novel way to look at technologies and innovation. And we know that this is a topic that is dear to your heart. So innovation is key, of course, on the production side of things, and you'll get to comment on Tadeu's input earlier. But also, what other innovations can one think of when it comes to the business model, also the technologies that can enable and unlock demand, thinking about AI, blockchain, but also other potential technologies?
Excellent question, thank you. So I think fundamentally, innovation is going to be important across the value chain. And what we spoke about just now, those are core technologies to convert iron ore to steel. So of course, Tadeu's technology, molten oxide, I think presents fantastic potential to do it in one step. We're also speaking about DRI. Again, this is one of the core technologies. And as I said, I don't think there is a magic bullet that can solve the challenge overnight. So until we get there, we need to pursue a number of technology pathways to try to decarbonize the massive challenge we are facing. But then one thing I want to mention is that regardless of technology, regardless of the core technology, we need so much energy. So it's really the cost of steel production is significantly premised on the cost and availability of green electricity. And that's the reason through the X-Carp Innovation Fund, we're also looking to invest in some of the most promising technologies when it comes to energy. So we invested in renewable energy. The challenge of renewable energy is, of course, its intermittent nature. And our facilities require energy 24/7. It's really around the clock. And that's the reason one of other investments we made is in long duration energy storage. It's a company called Form Energy, which is based on iron ore again. So it's not lithium, it's not one of those critical minerals, but it's iron ore, which is abundant. So that again presents an interesting potential to store energy for more than 24 hours. So it's actually multi-day storage. We also invested in advanced nuclear energy. We think nuclear has to be part of the energy mix, considering all the energy requirements, also considering the requirements from AI perspective. So I think that's something, if we speak about the innovation, of course you need to focus on the fundamental technologies of conversion of iron ore, but at the same time you need to look at energy, you need to look at a number of other things. And to your point on AI and blockchain, I think one thing we're all aware of is that we are not fully aware of AI potential. When it comes to blockchain, 1 ton of steel, if it's produced through the traditional blast furnace pathway where you use a lot of coke and coal on the way, is going to look exactly the same as 1 ton of steel produced using renewable energy, green transportation to deliver the iron ore, using recycled steel. So they're going to look exactly the same. So for customer, how can they get this comfort that this steel is coming through this completely decarbonized value chain? And I think this is where the blockchain and AI present, of course, an important consideration for us to really adjust. But as Tadeu was saying, steel industry is perceived as very conservative, but nevertheless, I think we remain optimistic that with all of those innovations, we really can solve this, put all these pieces of the puzzle together, because it's a massive puzzle how we can get to net zero. And then just to add, we spoke about, I know, like you said, it's a provocative statement that Tadeu made, that that's the only technology pathway. We're also looking at existing steel-making facilities. We can't change overnight. And one of the technologies we invested is a company called LanzaTech. They have a biofermentation technology, and we have a pilot plant with them in Belgium where we take a wood waste, and then through torrefaction we produce biocoal, which we then replace fossil coal by biocoal in the blast furnace, and we capture the off gases from this blast furnace, and using the biofermentation technology of LanzaTech, we aim to produce bioethanol. And things like that can present an excellent examples of circularity, and I'm a big fan of circularity. So to the extent you can recycle steel, to the extent you can use the waste from the production to produce something useful, I think we should absolutely focus on that. And then, of course, beyond that, looking at the fundamental ways to decarbonize steel in the long term, such as direct electrolysis of iron ore.
All right. Excellent. Thank you very much. So, Tadeu, again, back to you on the regulatory environment that we are in. So, as Nicholas has highlighted earlier, so regulations are important and key to incentivize demand and redirect supply. We've seen the EU's CBAM, which will essentially tax steel imports that are not compliant. To which extent regulations such as these will influence demand and supply, and also how important is regulatory convergence across the different parts of the world in order to really make an impact?
Sure. Well, it's starting with the last one. It's super important, right? We have to have something that is a result of cooperation because you're going to cross borders. And the carbon tax is absolutely necessary. Europe understood that first, and it's going in that direction. And incentives are also important. So Europe see and look at what the incentives that are being developed in the United States, and they don't dislike that model either. I think we need the carrot and we need the stick, for this transition time. It is a transition time, Irina. I mean, everything that helps is okay. Problem is, eventually we need to solve the whole problem, right? And during this transition, you need incentives and you need the taxes, and has to be done in a concerted way, no doubt about it. Now, the thing is, this thing will come, and demand will be the king. The consumer will be the king.
Yeah.
So the minute that we have a commercial product that doesn't emit anything, and it's green and it's not dirty, whoever wants to continue to do dirty stuff will have to pay. Either will pay because whoever does clean get a premium, but always dictated by the market and the demand, right? I think we are seeing these things. The end of the chain is demanding. In the automotive, guys are demanding that that the materials are decarbonized. Everyone wants to have a green product, right? And so it doesn't happen overnight, like Irina said, of course not. So the capital that is invested in manufacturing steel eventually will need to be replaced. At that point is a good point to have the new technologies to replace that capital. And we are talking about some years, right? But eventually it will be, and whoever does dirty work will have to pay one way or another. And it has to be done in a concerted way, for sure.
Okay.
Today we don't see that. We see some areas like more incentives, some others like more taxes. Eventually, I think we will meet, converge and meet at a certain point.
All right, thank you. So last question for the day. I'll go back to you, Nicolas. You've discussed earlier the cost side of things and the challenges around creating a competitive cost structure for the decarbonized metals in general. So that brings me to the question of financing, right? So we know that green steel technologies, for example, require larger upfront investment than conventional steel. This, compounded with uncertainty of demand, technology risks, etc., make these projects a bit more risky, a bit less bankable, potentially, than other conventional steel projects. So how can the industry overcome these financing challenges? What are the mechanisms that we can put in place and the ecosystem of financing that needs to be put in place in order to alleviate this financing challenge?
Great. So the first thing that I would say is that regulators should understand that this industry will not arise spontaneously, because projects are not viable economically at this moment. So you look at DRI with hydrogen, or if you look at a full-scale molten oxide electrolysis, most likely will not be financed today by any bank. So the supply program from the government and the subsidies and the grants, the ones established in the European Green Deal, or for example in the Inflation Reduction Act in America, are fundamental for resolving this program. So this problem, those programs cannot be stopped and should be strengthened. The second thing, I think, and that's our job, is to secure offtakes. I think it's very important that we, at the same time, we get the grants and the support from the government. We go to a market and we say, who is the one who is willing to sign an agreement, a long-term agreement for 10, for 15, 20 years, in order to commit for 60, 70% of the production of this new technology. I think that's very important, to have, at the same time, the security that we will have the demand. With that in your hands, you can go to the banks and finance the project without any problem. But I think you have the three, you need to have the three pieces. Very, very important. And finally, I think green finance is something that we have to develop a little bit more. When you look at the gaps between conventional financing and green financing, are still very weak. I would expect, I don't know, 50 basis points at least of differences for the same amount of money and the same time frame. And today, the differences are really lower than that. And I tend to believe that the investors and the banking community should also put their own efforts on trying to support these kind of projects. I think those are the three pieces. Government regulation stimulate the supply, the long-term contracts. I think it's important that we go to a market, and third, the green financing, or to strengthen the green financing schemes that we have today.
Great, excellent. So that brings us to the end of this panel. I'd like to thank you very much, our three panelists. And I have to say, I'm coming out of this discussion with more solutions than problems. I had come in with actually more problems than solutions. So thank you very much for your contributions.
And thank you, Frederick, for your moderation.